Imagine trying to solve a complex math problem using only your fingers and toes. For most of human history, that was the reality. Our story of the computer begins not with silicon and screens, but with a simple need to count. It starts with the abacus, an ancient Mesopotamian tool of beads on rods, one of the first devices designed to lighten our mental load. For thousands of years, this was the peak of computing technology. Fast forward to the 1600s, geniuses like Blaise Pascal and Gottfried Leibniz started building intricate mechanical calculators with gears and levers, machines that could add, subtract, multiply, and divide. They were marvels, but they were still just calculators. The real leap in thinking came in the 1830s from a man named Charles Babbage, often called the father of the computer. He dreamed up a machine called the Analytical engine. It was a mechanical beast that was never fully built, but its design was revolutionary. It had a processor, what he called the mill, and a memory, the store. It was designed to be a general-purpose, programmable computer. And working alongside him, Ada Lovelace saw its true potential. She realized it could manipulate more than just numbers. It could follow a set of instructions, an algorithm. She wrote the world's first computer program for a machine that didn't even exist yet. But these were all mechanical dreams. The true revolution needed a spark, and that spark was electricity. The 20th century ushered in the era of electronic computers, and they were giants. The most famous was ENIAC, built in 1945. It was a monster, filling an entire room, weighing 30 tons, and powered by nearly 18,000 fragile, energy-guzzling vacuum tubes. It was built to calculate artillery firing tables for the army, a task that took a human 12 hours. ENIAC could do in 30 seconds. But to change its program, you had to physically rewire it. A crucial breakthrough came from the mind of John von Neumann, the idea of a stored program computer, where instructions could live inside the machine's own memory. This made computers flexible, adaptable, and infinitely more powerful. Still, ENIAC and its kind had a major problem: those vacuum tubes. They were unreliable and generated immense heat. The future of computing couldn't be built on glorified light bulbs. It needed something solid. And in 1947, at Bell Labs, scientists delivered it, the transistor. It was tiny, reliable, and used a fraction of the power. The transistor was the invention that allowed computers to finally start shrinking. The next leap was even more profound. In the late 1950s, engineers Jack Kilby and Norbert Noyce, working independently, figured out how to pack many transistors and other components onto a single tiny sliver of silicon. This was the integrated circuit, the microchip. This invention kickstarted an incredible exponential trend observed by Intel co-founder Gordon Moore. He predicted that the number of transistors we could fit on a chip would roughly double every 2 years. This Moore's Law has been the engine driving the tech industry for over half a century, making our devices exponentially faster, smaller, and cheaper. By the early 1970s, this led to the microprocessor, an entire computer brain on a single chip. Intel's 4004 was a landmark. Suddenly, the idea of a computer that could sit on your desk or even in your home was no longer science fiction. The personal computing revolution had begun. Machines like the Apple II and the IBM PC brought computing into offices and homes, but they were still complex. The final key to unlocking computing for everyone was the Graphical User Interface, or GUI. Pioneered at Xerox PARC and made famous by Apple's Macintosh, the GUI gave us icons, windows, and a mouse. You no longer had to be a programmer to use a computer. You could just point and click. Once computers were personal and easy to use, the next logical step was to connect them. The 1990s brought the explosion of the internet and the World Wide Web, transforming these individual machines into a global network of information and communication. Then in the 2000s, the mobile revolution put that network and a computer more powerful than the Apollo moon mission right into our pockets with the smartphone. We moved our data and applications to the cloud, accessing them from anywhere. And the evolution hasn't stopped. Today, we're in the era of artificial intelligence, where computers learn from vast amounts of data to recognize your voice or recommend a movie. We're on the cusp of quantum computing, which uses the strange laws of quantum physics to solve problems that would take a normal computer millions of years. And we're pushing computing to the edge, processing data on smart devices themselves, from your watch to a self-driving car, for instant responses. From beads on a rod to room-sized behemoths to the quantum realm, the history of the computer is a relentless story of miniaturization and acceleration. It's a testament to our unending desire to solve problems, to connect with one another, and to augment our own minds. This journey is far from over, and if the past is any indication, the transformations to come are beyond anything we can currently imagine.